morning, everybody. My name is Philippe. I'm working at the European Space Agency. This is a huge stuff. And today I will only focus on this, which is also big, our planet. Because at ESA we do a lot of things, from launchers to exploring the universe, to transferring technologies. But my main focus is what we call Earth observation. This is using satellite to look at our planet and creating information services and also science with this data. And this is really the focus. All the satellites is just a technology to help monitor and manage this. This is our habitat. We have only one. I'm always starting talks with this picture because I think it's emotional, basically. And it created, when it was taken, a wave of emotions, people realizing they were on a small planet in the blackness here, and that it was limited in terms of resources. And you see here the atmosphere, the size of it extremely thin. It's like a hair on a big football, if you want, which is enabling us to live and to protect us from radiation and to breathe, etc. So it's very fragile, and we really need to care properly about it. So what we do in ESA is to launch satellites that monitor this on a routine basis, and I'm going to talk about a constellation called Copernicus with satellite called the Sentinels. And they monitor different parameters of the Earth, like a doctor is monitoring not only temperature but pressure, different what we call the body metrics or the vital signs, in order to understand the health of the planet. And this is not only data, there is a whole processing chain behind it to transform this data into information, to understand the health of the vegetation, the ozone hole, the cloud for meteorology, the vegetation extension, atmospheric chemistry, etc. So you can basically see everything from space. So what we try to do is to provide you guys with a kind of data set, a kind of digital planet, on which you can build your own services with your startups and your analytics. And we talk about big data. We are at the order of petabytes of data, so we need techniques like machine learning these days to do this. Otherwise, if you look at each pixel, which is 10 meter by 10 meter, it would take you more than 100 years to understand what's happening on the planet. So we need to make it automatic, and we will see example later on. Making it automatic is also challenging because you don't know what's in the black box. So we still need the scientist in the equations, I'm afraid, to really interpret correctly what's happening. And this is the infrastructure we put in space for you. This is totally free for you, the data. It's paid by public money up front. And it's totally unique. Europe is actually leading on this because we launch a family here of satellites called the Sentinels, monitoring the planet at 10-meter resolution twice per week, both in the optical domain and the radar domain, also looking at atmospheric chemistry with different resolution. The new thing as well is that this thing is likely to stay. So you will have continuity of the data for the next 50 years, always the same data, plus the enhancement of technology. So you can invest, because one of the issues we had before is that we had research satellite and we didn't know if they will last, so people didn't want to really get this into their decision process. And with this, we get meteorology, science mission, and today there are a new commercial layer coming up with small satellite, which is also disrupting this space, providing very high temporal sampling, like daily, and very high resolution. Major difference is that you need to pay for it. So there is a full synergy of the type of capability. And we need to put this data in the context of new data sets coming up, like drones, IoT, etc. So for startups, it's really an exciting time. There is a convergence of technologies, a convergence of capabilities in terms of computing, open data, and a growing demand for this, because the Earth is really in a bad state and we need to manage it properly. So business, corporate, society is calling for information services. And the trick is, of course, to transform that data into the information. This value chain can be very long. It needs full ownership of the user. So there is a lot of networking, asking the user what he wants so that you tailor your service. So that's where the added value is coming. And most of this now is to be generated automatically through machine learning and through a multivariable approach. If you remember the different signs of life, the trick is to actually correlate everything to understand the full health of the Earth. Because people tend to be in silos, they look at one aspect. So that's where, for me, that the frontier is really this integrated view. And AI is rising very fast in our field for automation of satellites, for new services, for creativity, like this is Sentinel-1 as seen by Van Gogh. This also highlights for me the limitation of AI, because I call it the curse of beauty. There are a lot of people now trying to make radar data look like optical data using GAN scheme. It looks very good, beautiful, so people believe it's the truth, but when you compare to reality, it's different stuff. So you have also new issues there linked with the ability of this to be so realistic. Okay? And we are really in a state of flux and disruption in the space agency because of these new technologies and the convergence with other things such as reusable launcher from Elon Musk, venture capitalists focusing now on your stuff, space, like 7 years ago, they didn't want to invest, too risky. Then there was a wave in the Silicon Valley, and now everybody wants to invest in space. They think it's the new frontier. Not only the big guys like Jeff Bezos, Elon Musk, etc., but also investor who thinks that you can have a 10x, if not 100x back, because it's already paid for by public money, and the marginal value you put on it can have a lot of commercial value. This is an example we did within the lab I'm working in. It was a use case with the World Food Programme and UNICEF. So we really tried to impact the life of people in the field and children. And they wanted to know about the food resources in Africa, in Malawi. So they had a drone campaign because there is no regulation for drones there. There is a corridor where you can try everything, transport with drones, etc. So they mapped the crops. Some farmer identified these crops. We put machine learning to extend this. It worked well for some crops, less for some others. Discrimination is not always perfect. And the key is to extend this to the resolution of the Sentinel, which is 10 meters. Because if you can move the learning from the field at high res with the drone to the medium res with the satellite, you scale up. And that's fantastic for them because they can then optimize campaigns, increase representativeness, and then scale up at the region, nation, and continent level by a few clicks. So this opens totally new door for them on how to do operation. And this is enabled by the machine learning, because this transfer learning is not the traditional way. We also do challenges in order to get AI guys. Our big problem is to get AI guys. That's why I'm here today. They all fly away somewhere else. But when you told them there are 15 petabytes of data which is free on the state of the planet, weather, environment, climate, all our economy depends on this, and we need your help to actually mine this, they get excited. So that's my main message today, is that it's all there, free, and we need new perspective on it to actually create new services. So here we were putting together a team of 5 with almost half being EO, Earth observation, the other half being AI. This guy comes from DFKI here in Germany, and he created a startup after this challenge. And 2 mentors, and they stayed 8 weeks in Oxford and 1 week with us. And they created a kind of super resolution scheme for disaster management. And it has spillover effect because UNICEF, who saw this, said, oh, wow, that's impressive, because it's like having superpower. You have open data 10-meter resolution, but by using temporal information, you can zoom in. It's amazing when you think about it. And they want to make this operational. So this year we have another FDL. We have 2 teams, one disaster and one climate. Unfortunately, we selected already the participants, but if you want to be a mentor of an observer, let me know, because fresh ideas are always good. So what we want to do now is to bring this capability in space, directly on the satellite. It might look not new to you, because AI at the edge is routine, possibly. But for us, we are really old, because space is a very dirty environment with radiation. So computers have not evolved as fast as on Earth. In fact, we're still using technology of 10, 15 years ago, because they are not radiation checked. The new technology, like the chip, are so efficient that even if you upset them, they still work, it seems. So now people are just trying out. They put NVIDIA chip, they put, we will do a satellite in September. We will launch a satellite with the Movidius chip, which is one for your mobile phone. It has a heritage of space technology in it, so it will resist radiation. It has been bombarded. And we will do computer vision. And we are bumping into new problems, like computer vision is 3 bands, and we have 50 bands. So are we throwing 47 bands away? How can we actually make things happen by transferring technology from existing fields which had not the same problematic? And again, that's where I need your brain there. This is the satellite. It's actually amazing. I myself being in the business for years, but to see this is just amazing. So 6U, it's this big. Satellite is this big. There will be 2 satellites, 2 mini, talking to each other through a laser and a radio link, exchanging computing power. One will have passive microwave and radar, and what we call GPS reflectometry. And the other one, a hyperspectral and a thermal. And putting this into that little box is mind-blowing. In fact, many engineers still think it's not possible. The hyperspectral is creating so much data, we don't have enough bandwidth to download it, so we will use the chip to better understand what to download. And that might change totally the way we do space in the next 10 years, because if you start to put the intelligence on board, you can make space for the stuff. The antenna can be smaller because you can just download some small information directly on board. And you can get it someday on your mobile phone. So that will disrupt the whole ground segment by bridging the last mile. And this is the view, the path to mass market. So what we try to do now is to have all these sensors which are disconnected because they have been built with specific purposes to talk to each other and act as a kind of swarm intelligence. This is a big job, but this can unleash really the power of all this capability. And that was my last slide. Thank you very much.
Thank you. Thanks a lot. You want the... Because I have no idea what you're doing, I have to say. I got the briefing. Yeah. But that's amazing, because you can just tell us. Thanks a lot. I think what's also interesting, people can apply constantly to your program and just talk to you about the data. So in case you're doing that, we also see a lot of startups looking at computer vision and Earth data.
Yeah, just a quick note on this, if I'm still on. Yes? Houston? Okay. ESA is also a funding agency. We try to cover the whole value chain of business from the incubation. So you have a crazy idea, you want to build a prototype, there is an incubation center. There are actually 13 in different countries. You can apply for this. But once you get a bit more mature, we have also a call for innovation proposals where you can test out stuff with user. So if you want more information, just talk to me. But this is a really cool field to be in, and we will see why.
You're around the whole day.
Thank you very much. There's also the Copernicus Masters, which is also partly financed by ESA, where you can just apply with a business idea. We also did this 2 years ago when we started with LiveEO. And actually, I'm wondering that you don't know us, because we are venture capital back from Dieter von Holtzbrink. So Holtzbrink, they're 2 brothers in Germany, and both have a venture capital firm. So what are we doing with LiveEO? Before I tell you this, I just want to get a feeling about the audience. Who of you already worked with data from space? Is there anyone? LiveEO employees don't count. Okay, and who of you works with AI? Okay, so a lot. It's great, because we just heard in the talk before that the space industry, it was very close in the past. I'm also a space engineer, and I wanted to go into the automotive industry because in the past it was very, very conservative. This is changing now. So with data from space, we have to get more people from other industries into the domain. And in the Silicon Valley, of course, in the past years, this was already done. Now I will show you what we from LiveEO are doing, because we are solving problems here on Earth. For example, our goal is to monitor the biggest machine on Earth. What is the biggest machine on Earth? Well, you may not believe it, but it's the US-American electricity grid. The US-American electricity grid has a length of around 9 million kilometers. And compared to our standard in Europe, it's completely different. On average, every customer in the US has a downtime of the electricity grid of 480 minutes. That's an average value. This means that in some places, for example, last year in New York, in the area of New York, Con Ed, the energy provider, they had around 10,000 people without electricity for a week. We cannot believe it. It's the US, and it was around New York, so not somewhere in the middle where no one lives. And we got very nice business numbers in the past month. Vegetation management, only in the US, is a market worth more than $1 billion US. And only one customer, which we just convinced of a project 2 days ago, only this single customer is spending $300 million US on vegetation management a year. I bet you didn't even know that there is vegetation management. We also were really impressed. This is just the US. If you go to the entire Earth, there are more than 30 million kilometers of infrastructure grids. And the verticals, railways, pipelines, and electricity. This is around 80 times the distance to the moon, so it's incredible. The interesting thing is that all those infrastructure grids, they're facing the same challenges. They're distributed over large areas, and you have to monitor them. This is today done in a very ineffective manual procedure. So people are walking alongside the grid, 9 million kilometers, no problem. And sometimes they use digital tools, but they're also often using paper and pencil. What they're also doing is they're doing aerial surveys with planes or with helicopters, which is, I bet, a lot of fun, but it's very costly. And some gas providers, for example, they are flying every 2 weeks along the infrastructure, and there are people sitting there and visually inspecting what's going on the ground. We all know, I think here in the room, that if you use AI applied on Earth observation data, you can solve the problem, and this is exactly what we believe. We believe the solution to this incredible monitoring problem comes from space, in particular from satellites. We already heard that there was a big change. We had the ESA perspective, but also in the private industry, it is completely changing the industry. This is the hockey stick. This is 2017, and this is continuing. So the number of satellites which are launched into orbit are rising. It's just incredible. And I really, as a space engineer, I couldn't believe that this would have happened 5 years ago. The interesting thing is that you have different data sources. So you, after this meeting, after today, you can go online and from the public program can download data for free and work on it. So the Copernicus satellites, you can see them on the left. They are very big machines and they are powerful, monitoring Earth and with a 10-meter resolution. If you combine this then with private data set, then the magic starts to happen. For example, this is a Planet Dove from Planet Labs from Silicon Valley. It's 30 centimeters in length. It can take images with a 3-meter resolution. The interesting thing is they have more than 100 of them in orbit, so you get it every day you can get another image from them. And then you also have radar satellites which can look through clouds. The cool thing about images from space, this is how we see the colors with our human eye, red, green, blue. But actually, data from space is it's not really an image, it's a measurement. A measurement in different wavelengths. So this is, for example, a visualization of the infrared world, which we cannot see. But the interesting thing is that if you use those different wavelengths, you can even, if you only have one pixel in a time series, can differentiate between different tree species. Only with one pixel, you don't need a CNN for this. And then also with radar data, it's really incredible what you can measure with this. The challenge is, and was always in Earth observation, to really find the business models. There is a lot going on in the agricultural domain because this is the oldest. It's also, there are a lot of big challenges. I will just show you how we are monitoring those grids regarding vegetation. And actually it starts with the problem from actually Deutsche Bahn in Germany. So they, in the media, we read a lot of newspapers in the past 3 years. Before we started LiveEO, there was a lot of political pressure on Deutsche Bahn because in the past 3 years, they had more than 800 collisions of trains with trees which fell onto the railway in Germany alone. I will show you how we are solving this problem. So we have a risk through vegetation, we have satellite data, we are applying AI, and how are we doing this? This is a spot in Düsseldorf. This is a high-resolution image with sub-meter resolution. You can think that, of course, you can, with image recognition, detect the vegetation there. We did this with a 10-meter resolution already, and we know where the railways are. And just if you have this classification of the image based on AI, you can already find risky spots of the railway. So you can tell Deutsche Bahn that they have a bigger risk, for example, here compared to here. That sounds easy. The interesting thing was for us that Deutsche Bahn, they didn't even know how many kilometers are exposed to railways. They're operating 33,000 kilometers and they had no idea how to start, where to start, and how to solve the problem. Their plan was actually to send their inspection teams, their vegetation guys, around 1,000, for 5 years alongside the grid with new tablets. They never worked with tablets before, to get the information on the vegetation next to the railways. We were in the procedure with Deutsche Bahn. We told them that this doesn't make sense. The people are complaining because they have to cut back the vegetation. Now they also have to assess the vegetation. And then after 3 months, they recognized 5 years with 1,000 people. That's not enough. It will take longer. So we scaled our architecture and did this for entire Germany already. This was our big first customer last year. And now we can tell Deutsche Bahn exactly where they have the biggest issues, because what's so powerful about the data from space is that you get the overview effect. So we now can also aggregate the information. So we can tell the managers of Deutsche Bahn, there are, for example, 34 regions which the infrastructure in Germany is distributed. And they all have their own budgets. They all have to hire people. And the center in Frankfurt of Deutsche Bahn, they have to allocate the resources. And you just have to imagine, they didn't even know before where there is the bigger problem. And the differences are huge. For example, here you have around 70% of the railways exposed to vegetation. If you drive to Berlin, you may see that there is a lot of vegetation. In other spots, it's only 20%. So if you allocate the same budget per kilometer everywhere, it just does not make sense. And with the power from Earth observation, we can now solve those problems directly for the entire grid. This is also, a lot of people are working with UAVs, but the challenge with UAVs is always, for example, for the US grid of our customer, they need around 1,000 UAVs in 100 days to monitor the grid. And we can already monitor the entire grid, and you don't need millimeter resolution to solve those business problems. So we do not only sell the maps, so we aggregate the information and combine it with business information. AI is not only applied in the image processing, also in the complete pipeline. So you know, when you already have aggregated information onto every single meter of the railway, Deutsche Bahn, they have a lot of information hidden there. the electricity providers also have a lot of information hidden there, and we just want to gain more insights out of this by using AI technologies. And then what's also really powerful is what we from LiveEO did is we developed a mobile application because I think the ones of you which are familiar with AI know that once you have a feedback loop of hundreds of people or maybe thousands of people in the field who are gathering the data and give you a feedback loop, you then really have a login and can solve even more problems. So yeah, this is what we're doing. Based on satellite images, we can provide a full stack solution for infrastructure management. Now I just want to give you a few examples of some challenges that we had and then also some opportunities. So what you can see here, for example, are the Sentinel tiles from the public program. And Earth observation data is really, really heavy. So we made some Amazon instances degrading, so the hardware was crashed, was not our fault, just because the processing time and the cloud resources you need are just immense. And to give you an example, every square here is corresponding to, on the optical domain, 1 to 2 gigabyte. So one timestamp of this of each quarter 1 to 2 gigabyte. For Germany, you need around 70 of those for just one timestamp. When you monitor every month, you can see how those numbers go up. And then, of course, the challenge is for people who are not from the Earth observation domain. You have so many different data sources, and they all can be used to solve different problems. But to get this understanding, you will have to dive into the data. For example, what you can get out of 10-meter resolution is nice, but what you can get out of 30-centimeter resolution is incredible. But it costs a lot of money. Yeah, that's always a challenge for us, also for customers. What kind of data source do we want to buy? Maybe we can solve problems with 80% accuracy with the free data. And then also, if you can buy high-resolution data, of course, those bounding boxes you all know from other computer vision tools. This also works on satellite imagery, and there is a lot going on there. For example, Orbital Insight from the US, they're monitoring how many cars are in front of Walmarts and can then make an estimate of their quarterly results. So in the finance industry, there are also a lot of different applications. And this is also a very true problem. Earth is a sphere, sorry flat earthers, but the problem is the images are flat. So, and there are, I don't know, so thousands of researchers and people, they are making their own projection. So there are thousands of different projections, how you make the 3D world into a 2D images. And yeah, this is just from our chat. A small example of our daily work. Those are labels from trees in Berlin, and another intern from us wanted to open the data, and then he was not in Berlin, he was in the United Arab Emirates. So this is always a challenge. You always have the geospatial component. And then yes, daily images are nice. This is the Tiergarten. It's really the Tiergarten. And this is also a challenge in winter, why you really, why maybe in the future you will see more in radar data. And this is also an opportunity. You have different, like in the pre-processing, in the processing, in the post-processing, at a lot of different levels you can apply AI technologies. And this is an example of a radar signal, and maybe this was also what the ESA guy told you. When you apply filtering methods, this is a conventional filter without neural networks. It already works pretty fine. And this is a filter based on neural networks. And so scientific papers now are really seeing that it's outperforming the conventional filters. Even like problems you couldn't solve in the past with radar data, you may now can solve. And then there is another very powerful thing about Earth observation data. When you now want to start a UAV company, for example, you have to fly and get the data. If you want to start with Earth observation data from space, you have historical data over the last decades, and over the past 3 to 4 years, you have nearly daily images. You can already get historical data. You can train your algorithms, and this is very powerful. This, for example, is over 1.5 years, just one tree, 1 pixel. So every color is corresponding to 1 tree in 1 pixel, and with a time series, you can see how the tree is really living. And then, of course, what is now changing after all those satellites are in orbit, you need access to the data. And this is a very cool startup also from Berlin, together with Airbus and BCG. They created Up42, where you can run and build geospatial applications and get access to high-resolution data. There are also others, but I really, if you want to start with this, I really think you should have a look there. It's very, very cool. And then regarding the applications, you can solve so many problems. This, for example, is a spot in Leverkusen, a construction site. And you really can see with the daily images how this construction evolves. And the past days, I was in Frankfurt until yesterday for one of the biggest construction projects from the last decades in Germany. And we also want to monitor the progress from space for those construction sites. So the first constellations are there. You can already work with it. But what's really unbelievable is what the future will bring to us. There are actually 2 startups, one from the US, one from Finland, which are building a radar constellation where you can get data every hour for every meter on the planet. And this is then the next dimension. So I really would love to see more startups in this domain, because it's unbelievable what you can solve with this. And the use cases, they scale without borders. For us, we started with Deutsche Bahn, and now we are operating in the US. We are monitoring grids in the US. We are monitoring grids in Austria. For us, it just don't care. We get the data. It's the same data, and actually also the same business problems. And we already saw the blue dot, and it's just imagine how many problems you can solve if you have this overview effect. And I think really for this century, all like the biggest challenges we have, climate change, the natural environment, urban planning, all those problems we can solve with technology from space. We have to first know what are our problems, how big are our problems, and there is no other possibility to do this with data from space.
So I presume you all take it for granted that we always have access to electricity. Well, yeah, we just learned that there are huge outages in the US. I didn't know that. Like, my last outage was at least 2 or 3 years ago. I am used to having access to electricity at home, in the office, in cafes, or even on the train yesterday from Amsterdam to Berlin. But until 2 years ago, I never really thought about this huge infrastructure that was needed to actually make sure that we always have access to electricity. Until 2 years ago, when I met with the team at a company called Wien-Energie. So Wien-Energie is an Austrian utility company, and it is their job to make sure that everyone in Vienna has 24/7 access to electricity. And like we just learned, there's a lot of infrastructure that comes looking around when you want to try such a thing. So this team in particular invests in renewable energy assets like solar farms. And this is a pretty big investment. These solar farms are huge, they cost a lot of money, and of course we want a healthy return on our investment. But they're obviously outside. And over time they will tear down and break down, which is a problem for this team. Because a broken solar farm, or a part of a solar farm, because obviously it doesn't break all at once, is no longer producing energy. So also no longer producing revenue. And while it's standing still, it's also, you're losing out on money, but you have to invest more money to repair it to get it back online. So this is not a great thing. And preventing this is really hard, because it's not quite as big as the electricity grid, but these fields can be really, really massive, spread out across the landscape or scattered across rooftops in the cities. And right now, if you want to inspect a solar farm like this, they indeed go out in the fields and they take pictures. But since they're so big and that takes a lot of time and money, they will only sample a part of the field. So they might look at the area in the bottom right, but they have no clue what's going on in the top left. Another problem is that they're measuring the energy production, but that doesn't really tell you much about how it's doing. So you can look at the energy production, you can see it going down, but you don't know if maybe a panel was stolen, if there's a cloud overcasting, which causes shadow, so there's less production, or if it's an overgrowing plant, which you can actually solve by taking away the plant, and then the panel will produce more and more energy. So we know that we need to do a better job, because in the future we'll obviously have more renewable energy sources, but right now we don't really know what kind of actions we can take to stop these things from degrading. And that's what we're working on to solve. So together with Vereniging, Birds.ai has developed our first product last year. And we aim to give these, you call them operation and maintenance managers, a bird's eye view of their solar farm. So they want to see in one glance how the whole solar farm is doing. They want to then zoom into individual modules, individual panels, and they want to track defects over time. So what you can see is that small damages might actually evolve into much bigger problems over time if you don't do anything. So since this is a more technical talk, I have the privilege of explaining how we do that and what kind of data we use. So you've already seen the drone in the previous image. And obviously, step one is to collect the data. So today we're using drones because we do need a much higher resolution than, I don't know what Pierre mentioned, 10 meters per pixel. We look at a resolution of, I think, 5 centimeters per pixel, so we can really see all the actually bird droppings on the panels. So we don't fly the drones ourselves, but we find a drone operator in the country that we're inspecting. And this drone operator will collect images not only in the visual spectrum, so regular RGB images, but they also use thermal cameras, because a lot of the defects on solar farms are only visible in the thermal spectrum. That data then gets uploaded to our cloud platform. And that's where we get to work with processing the data using AI. We specifically use supervised machine learning algorithms. So we trained, algorithms by showing it many examples of defects that we've previously seen. This has all been done together with actual inspection experts, so the data is really high quality, and we can get pretty good results out of that. Just to give you an idea of what we're looking at, if you look at RGB images, you'll indeed find bird droppings or glass damages or overgrowing plants, and also missing panels or missing clamps, which are the things that keep them into place. If we look at thermal data, you see if there's a hotspot. It's obviously that there's something wrong, but we can also tell what is causing the hotspot. So it might be a broken substring or a hot junction box. To me, 1 year ago, this all sounded like, what's a hot junction box? But there's very specific reasons of why they break down. And you can, if you know the reason, you know what to do to fix them. That's not where data processing stops. We also just simply look at where the panels are. So we draw bounding boxes around all the panels. And by doing this, we can create a sort of a blueprint. So that brings me to this next step, is that we do data enrichment, if you want to call it like that. We add more information to the visual data that we collected. So on the blueprint, we use that to create a schematic overview. We're able to position all the problems that we found. We indicate with colors what the severity level of that is. We attach recommended actions to all the things that we found. And then in the final step, we visualize all this information to the customer. So this is in the very traditional PDF report. But we also build our own platform which is more interactive, where users can filter and zoom in to the data we collected. And this is a small screenshot of what that looks like. So now to get a bird's eye view, the customer only needs to log in to our platform, which is called Bird's Eye View. They get their view of their whole solar farm. The data is complete. We've seen the whole farm. This is possible because we use drone operators, and we use automatic image classification, because this wouldn't be possible if we would look at the images manually. There are also recommended actions attached to every defect that was found. So with this information, the customer may actually choose to repair something or send someone out to fix a panel, replace a panel, or file a warranty claim. So in this way, they know better what kind of actions to take to prevent losing money on their investment. So today we're talking about what we are doing with that and how our business model works. So I just want to quickly explain what that looks like for us. So we sell the access to the platform as a software as a service license. So customers just pay a monthly fee to get access to that state of their asset, which keeps updating every month or year or however often they want. And to actually update it and create a new inspection, they pay a fixed fee for the analysis, where we actually go through these data processing and enrichment steps to keep the asset up to date. What we are doing is we're using AI to actually increase our personal profit margin. So we can choose to do everything manually, which will obviously cost a lot of time and money. But by applying AI, we're actually able to turn this into a scalable business because we don't have to hire 10 more people if we want to analyze 10 more images. And honestly, artificial inspectors are a lot more cheaper than human inspectors. So far, we have been working with customers in the Netherlands and in Austria. So examples in the Netherlands are Axo Nobel, and Zebra, which is a solar farm consultancy company. And our first customer, which I already mentioned at the beginning, is Wien Energie in Austria. We have detected last year many defects in many solar farms. So last year we were still fine-tuning our technology and building our product. We looked at 9.7 megawatts of solar farm. To me, that didn't mean anything. So I just listed the amount of panels, which is 40,000 and a little bit more. Actually, today, we're flying another solar farm with 20,000 panels. So that will be a fun week next week to add them to the platform. And luckily, I'm not doing that alone. There's a great team. So my CEO and co-founder, Camille, is currently overseeing the inspection of this humongous solar farm. And there's also a bunch of developers on AI, but also full stack business developers and production managers. My name is ANOUK. I've been working in AI for over 9 years. A lot has changed since I started my studies at the University of Amsterdam. And I was actually working on student projects together with Camille from 5 years ago today as well. So it's an exciting anniversary for us. And from that student project, we actually got the idea of we were doing something similar with drones and solving a cool challenge. And we found out that people need a bird's eye view of what they own. And they don't only need the bird's eye view of solar farms, they also need a bird's eye view of wind turbines, of cell towers, sea vessels, chimneys, and indeed the electricity grid. So we are really scaling up our team this year. We're looking for funding because we believe there's many more assets that are not supposed to break down unexpectedly. So right now, I told you we're using drones with thermal and RGB cameras to visualize how a solar farm is doing. We're doing a similar thing for wind turbines, where we also use drones because they're pretty large to reach manually. There, we're not only predicting defects, but also the severity and how that will develop over time. And new business cases that we're looking into might also include coatings on things like sea vessels. So there it's more of a manual approach where if you dry dock a boat like that, you send out a couple of inspectors with iPads. They take a photo, but it's really hard to estimate what kind of damage is happening in coating. So we want to use AI to make sure that all the data gets labeled in the same way. So that's a different use case, but the same problem. You have a big asset, you want to know how it's doing, and you can scale it up way easier if you use AI. So we're really excited to be here today. These are my contact details. If you want to help give our customers a bird's eye view of their assets so they can actually take it for granted that they don't break down, I'm really happy to talk to see how we can work together. Thank you.
Thanks a lot. May I ask you to stay on stage, and maybe Daniel, you can join us for some Q&A. We still have some time. Questions. So thanks for making up the time. Daniel was talking so much. No, but we still have a bit of time for the other speaker, and I think some of you guys might have some questions. So please, just raise your hands and then, sorry? Yeah, you don't have one? Yeah, I'll get you one. Can we have a microphone up here? Ah, cool. Shall we start here?
Yeah, why not?
Perfect. There is the microphone coming.
Thank you for the talk. It's very inspiring indeed. I have a question about the workflow. So where is your engagement starts and where does it stop? Do you already operate the drones and do the pre-processing and all the workflow till the analysis? And
Yeah, so it differs a little bit per customer. So some customers are already experimenting with drones themselves. But we are always involved in that process. So we created a flight protocol that ensures that we're collecting the right kind of data and that the quality is high enough. And if the customer is not working with a drone operator, we'll just find one in their area, which is quite easy nowadays. And then, yeah, we take the data from the drone operator. We go through that whole process always. If it's a new asset, we may ask for some feedback on the kind of defects and the damages that we need to find. We show the visualization, and that's sort of where it stops, but it would be really interesting in the future to also really communicate with the asset maintenance team of what kind of actions are they taking, how are they responding to the problems, and do they value our recommended actions.
At static problems, like, the trees, they're not growing that fast, so you take a picture and probably once a year or half a year where you have to cut them. Do you also do dynamic analysis?
Yes, therefore, so it always depends on the customer problem. And for example, for construction sites, like in the nature of a construction, it's very dynamic. That's why we are also like working on this in this domain. And then another thing which we realized, which also took a lot of time, that the frequency of the usage of our product does not depend on the frequency of our analysis. Because we have workforce management integrated, people are using our app in their daily life. They have their task, they feed information back. That's why we don't have to analyze every week with the satellite imagery. They're using our software every day.
Okay. So what would be the frequency
of analysis? Yeah. Most dynamic for construction site once a week. Okay. So every week an update about the state of a construction. Yeah.
Cool. There was another question, and I think we need the microphone for the video. So we have... Thank you.
You have solution for a special industry. Can you tell us something about the way from the idea to the startup?
So for us, for me, it started, like I said, 5 years ago. We were joining a global challenge to protect game reserves from poachers. So this was a very cool problem, but protecting rhinos instead of poaching rhinos, there's a lot more money on the wrong side. So we were looking for a more profitable business case than a non-profit goal, which is still part of the vision of the company. That's where we want to go back to. So we took this idea of we want a bird's eye view of the game reserve, and we started looking at industries that also want that. So we passed game counts, livestock management, agriculture. But as we know from the first talk, agriculture benefits from using a lot of bands, and that was really not our expertise. So then we looked at other assets, and we found that the inspection industry with drones was really taking off at the time. So there was a lot of steps in between to finding our product market fit. But it's been a good journey.
Yeah, for me it was an adventure. I was in Munich 3 years ago, like in the automotive industry at BMW, and I recognized I studied space engineering. I wanted to go into the space industry, so I said, no, I'm gonna do a startup in the space industry. And my first ideas, because I was in the wind tunnel there, were hardware ideas. So I wanted to build small set components or even small set systems. So I met my co-founder like tomorrow, exactly 3 years ago, who also wanted to build a startup in the space industry. And then I moved to Berlin. We shared our ideas of our hardware ideas and also of our software ideas. And we recognized we are around 5 years too late if we want to build hardware. So that's why we wanted to build a software solution. Our first solution actually was completely different. So we wanted to build a tourism application. So we wanted to classify beaches and build an affiliate-based model. So you could find a beach which is crowded, because you can actually measure how crowded the beaches are from space. I thought this may be nice. We talked to Trivago. They liked the idea, but then Sven and we said, maybe we can, with the technology, solve bigger problems. And this is. Then we made some analysis of some markets, and the infrastructure utility sector was our market, which we are now targeting. Yeah.